Hey there, Madeline here. Now, while there are many equally exciting components to building a Formula race car, today I'm going to be focusing my lecture on the topic of suspension. So, what is suspension? Well, in simplest terms, it's a system that connects the wheels to the chassis. But what's so exciting about that, you ask? Think back to the days of horse-drawn carriages, when there was a beam axle mounted at each end. It wasn't until the 1920s into the 1930s that race car drivers finally got smart and realized an obvious limitation of beam axle suspension. That is, an upset on one wheel will directly impact its neighbor. Now, without proper suspension systems, you have cars that look a lot like Barbies, just two sets of wheels connected by rods. Not a very smooth or safe ride. That's why innovators of the automotive industry came up with independent suspension systems. So the double wishbone AR suspension system, like what you see here, is what many Formula teams utilize. Now, the goal of any decent suspension system is to 1, help the driver maintain control of the vehicle, 2, to reduce shock from the road, and 3, to help the wheels stay on the road with as much force as possible. Why? Well, to answer that question, we must first consider what makes wheels roll in the first place. It's friction. Without friction, there would be a lot more sliding and a lot less moving. The function for determining the force due to friction is F is equal to mu n, such that mu is equal to the coefficient of friction and n is the normal force. When the tire pushes down onto the ground with greater force, the ground will push up on the tire with an equal and opposite force. That's just Newton's third law, folks. Now, the slip angle is described as the angular difference between the direction that the tire points and the path that the tire follows. The tire's coefficient of friction can actually be greater than 1 due to tire deformation. Now, the tire's coefficient of friction increases as the slip angle increases until a certain maximum value. But enough about tires. Let's talk about the heart of our suspension system, the noble spring. We define suspension spring rates as the force exerted on the spring divided by the spring's displacement. The wheel rate is equal to the spring rate divided by the motion ratio squared, given that the motion ratio is equal to the amount of wheel travel divided by the amount of spring travel. The wheel rate takes into the account that the spring must be mounted at some angle to the vertical. Now, when we analyze the full vehicle, the spring rates of the front, rear, and chassis act as springs in a series, such that the reciprocal of the equivalent spring rate is equal to the sum of the reciprocals of each component's spring rate. Another important consideration is natural frequency, given by the square root of wheel rate divided by mass, all divided by 2 pi. Now, the wheel rate in pounds of force per inch divided by mass in pounds is equal to displacement of the springs in inches. And there you have it. Those are the basics of suspension.